for talking about second-order science was that von Forster introduced the term but didn't say much about it. And it reminded me, as you know, some of the symbolism actually that you were using in your talk. There was, and I'm not sure that this was an idea that he was aware of or that might have influenced him, but there was, along about that time, a very well-developed notion of second-order logic. And basically, in a way, there was the zero-order logic, if you will, and the first-order logic, and then second-order logic. Zero-order logic might be thought of as propositional logic. Probably if you studied logic in college at some point, you remember the P's and the Q's and the if-thens and the ands and the ors and the nots. That's propositional logic. The P's and the Q's were used to refer to statements. The cat is on the mat, it's snowing outside, things which could be true or false, regarded as true as false. And then you would combine those atomic statements into molecular statements or compound statements using and or not. It's not the case that it's snowing, which given the reality right now would be false. It's snowing and the cat is on the mat, so on and so forth. Then there was first-order logic. And first-order logic introduced quantification. It was usually called first-order logic and identity. So it usually introduced quantification and the identity relationship. And in introducing quantification, it introduced quantifiers like for all x, for everything that you are referring to. If x is a man, then x is rational, something like that. It introduced predicates, is a man, is rational, which are neither true nor false, but you can predicate them of individuals to make true or false statements. And it introduced the existential quantifier. There exists an x, such that x is a man and x is rational, which would have different truth conditions. And then there was second-order logic. And the basic notion behind second-order logic was that you could quantify not only over individuals, but also over relations or predicates. So instead of saying there exists an X where X is in maybe universe of human beings, you can now say there exists an X where X is thought of as being a relation or a predicate. So I just throw that out because I wonder whether and to what extent that might have influenced his use of the idea of a second-order science, where he's talking about really the things that you're talking about. Now you're not simply talking about individuals, you're talking about relations, which would require individuals to saturate those relations in order to make true or false sentences. Now, a second thing, though, that I wanted to comment on just with Karl's is that you began with a question, or you raised a question, which I can no longer see without glasses, about zero, was it zero-order science or first-order science? He said, do we need first-order science? And the answer was definitely yes. And I find that interesting. I mean, I would agree with you that we need first-order science. But there is a very interesting question being raised right now, as I think you should know, as a result of the so-called big data revolution. So what is the big data revolution? Well, I think you all know we are able now to collect more data than ever before in the history of mankind. I think they say that in the past 2 years, we've collected more data than ever before in the history of mankind. And this has raised the question whether we need theory, which I want to propose or submit is another way of asking whether we need science. And this is really something that I want to focus on in what I'm saying, because one of the things that we didn't talk about much, or Karl or Stuart haven't talked about much, is what is science? What are we talking about when we talk about science? Now, you did mention universal and general theories. You say, you know, do we want universal general theories, or is science universal general knowledge, or is it helping human beings? I would say that, just take away the is, science is universal general knowledge that helps human beings. But the universal and general knowledge was always part of what people thought of as being science. This goes well back to Aristotle. It was systematic general knowledge. Why was it systematic general knowledge? Why did you want systematic general knowledge? Because you couldn't carry all of the facts in your heads. You know, you couldn't carry every little bit of information about every particular object that you may want to talk about in your head. So if you had a universal statement, like all men are rational, that enabled you to deduce all sorts of facts about other individuals who you regarded as men. So that was always the idea. What is science? It's a universal theory. Now, I understand that people use science in many different ways. The term science in many different ways these days. I mean, I ran a project on science here in DC a few years back, and my group, it was a discussion project. I had 2 panels with people who knew a lot about science. They came up with at least 24 different ideas of what science is. But when philosophers of science were talking about science, at least through the middle of the 20th century, they were talking about universal, general, systematic knowledge. When they were talking about theories, they were talking about universal, general theories. And that was basically the idea. When you said that when people began to say that all facts are theory-laden, it meant that already you had the bias of the theory in your interpretation of the facts that you thought you were talking about. Now, I point that out because today, with the big data revolution, there is a very real question. Do you need theory? People are writing articles about this and discussing it. Why might you not need theory? Because we have these little lookup devices now that are able to get you all sorts of information. And if you could imagine space, or logical space, as being perhaps some type of three-dimensional Cartesian grid, you would be able to, they submit, they would be able to pinpoint each fact, each individual fact that we might ever need to know. I don't believe it is possible, and I also have other reasons to be opposed to this, but if that were the case, you wouldn't need first-order science. You wouldn't need to have universal theories, because you could get every fact that you might thought you needed a universal theory, for which you might want a universal theory. I'm sorry, there are 2 hands.
Go ahead. Well, I've noticed increasing in the literature, an increasing, when you're a journalist, I guess, maybe not, an increasing kind of sloppy distinction between what qualifies as a theory and what used to only qualify as a hypothesis.
Yeah, well, I would think that. But even hypotheses would be general, universal statements. And that was a fundamental distinction that everybody made. That's why you have logic as it is. You had universal statements, both affirmative and negative, and you had particular statements. And the idea that you couldn't use inductive method to generate universal theories, of course you could. The problem was that the universal theory didn't follow from the evidence. And if you wanted to do it rationally, with the theory actually being supported by the evidence, you would want the theory to follow from the evidence. So, this was an important point.
The only thought I had was regarding the matter of big data. I think it is true that, you will agree with it, data obviously allows you to answer all the questions without any theory, so to say. Yeah. But it still does not talk about data that does not exist. Yeah, I see. Yeah. Past or current data.
Yeah, I agree entirely on this. I'm not supporting the idea of that. It's the end of theory, as some people have said. But I just am pointing out that the answer may not be so obviously true as Karl had suggested. Not only does the big data revolution, not only would that not account for future data, which I think is a very important problem. was part of the philosophy of science was very, very technical and esoteric, most of which are forgotten. But people like Carnap and in the early part of the century thought that, and even Quine thought that you could have like so-called extensive definitions, whereby instead of saying something like man is a rational animal, you just list all the members of the set. Well, that's a wonderful idea, except for what happens when the next baby is born. He's not a member of the set that you've listed, and hence he's not a human being, but we somehow have the sense that he is. But quite aside from that, that's a huge problem too. But how do you know what to collect, what data to collect? You're already using theory when you go out to collect data. So the prominence of theory, the importance of theory, I think is immense. It's immense in science. Now, my take on the second order science that Stuart has been talking about, well, there's so much there that I would discuss or criticize, and we can get into it at length. But I think it's important to understand, and I think that this is something which you tend to obscure, is that everybody in the philosophy of science for centuries have known about the observer. I mean, just think about the great philosophers of science who produced treatises on scientific method. Descartes, Discourse on Method. He's talking about the observer and the fact that the observer's senses may be deceiving him for all sorts of different reasons, so you can't trust his observations. Hume was talking about the observer and saying that his observations can't be deceiving him, although maybe what he infers from the observations may not exactly follow. Kant was talking about the observer. In the 20th century, everybody has talked about the observer, and what they have said is that, first of all, the observations that somebody may make are not foolproof for all sorts of different reasons. I mean, not only that your senses may be deceiving you, but they may be biased, they're theory-laden, they're value-laden, so on and so forth. So people have recognized that the observer exists. You would like to expand the philosophy of science, you say, so as to include the observer. The problem is, once you recognize that, which I think is wisdom for the ages, that observers may be mistaken for all sorts of different reasons, it doesn't go very far beyond that. Why not? Because you can't make general universal statements about which observers may be mistaken, or how they may be mistaken, or how they may be influenced, or anything like that. We know that colorblind people will not be able to see colors. So that's a problem with the observer. If you wanted to do scientific experiments that depended upon being able to recognize colors, you would not want that observer as your practitioner. But that doesn't take you very far. You know that people are biased. You know that people who support a theory may prejudice or may favor confirming evidence and may tend to ignore refuting evidence, and vice versa. But it doesn't tell you that they necessarily will. And it can't tell you that it necessarily will. So hence, it can't give you scientific knowledge about the observer. To the extent, and quite aside from that, we know that as a result of scientific studies. I mean, psychology has existed since Aristotle. This is nothing new. But there are very good reasons why you may tend to ignore it. You say, well, we want to talk about the observer. Wittgenstein had a very wonderful graphic in the Tractatus where he points out that these are removable, aren't they?
Yeah.
We did this once in Budapest. It was very funny.
Use the black one if there's
One of the participants was talking about reversibility of time, and he went up to the whiteboard and he drew whatever graph he wanted to review, and then he couldn't erase it. He couldn't reverse it.
Yeah, okay.
Okay. Any event, Wittgenstein had this wonderful graphic where he says, the visual field is not like this. I mean, Wittgenstein wrote in aphorisms. The visual field is not like this. What does it mean? It means it doesn't include the eye. The eye does not see itself seeing. The observer does not see himself observing. So how do we include the observer? We know of the observer's influence. Well, what do we need? Do we need another observer to be observing the observer? Perhaps. I'm not sure it's possible because psychological observations, we think, are private to the individual that observes them. But what do? Should we introduce another observer to observe that observer, to be scientific? So, okay, we'll introduce another one. There he is. He's observing now this observer. But what about him? Isn't he going to be possibly, as you say, biased, theory-laden, whatever? So we need now not just a second-order logic, a third-order logic, and a fourth-order logic, ad infinitum. And no matter how many you put in, the fundamental problem still remains. You can't generalize it. You can't say that, you can't even say that all Republicans are going to think this way, let alone all people. So you can't make these generalizations that you would like to make that would justify having a second-order logic. So my suggestion is we take the wisdom for the ages. We understand that observers may be, that their observation statements may not be totally factual, and then we move on from there, which in fact is what we have done. One of the things that I wanted to say about your presentation of the correspondence principle. New theories must reduce to the old theories.
Reduce to?
Reduce to the old theories. Well, what does that mean? I mean...
It means when one variable...
I'm sorry?
When the operative variable isn't present, the laws of the old theory apply.
Well, I mean, the way in which logicians talk about reduction, that logical reduction, is that you can derive the new theory from the old theory. The one reduces to the other. Well, why is it a new theory then? I mean, why isn't it just playing out the consequences of the old theory? New theory, first of all, the correspondence theory does not say that new theories must reduce to the old theories. It says that new theories must be able to account for all of the phenomena that the old theory accounted for. Einstein's theory doesn't reduce to Newton's. It would be Newton's theory then. Einstein's theory contradicts Newton's. They can't both be true. That's why you had to have a test to decide between them. So this notion that somehow the new theory reduces to the old theory, it's just mistaken. And to understand, it is a real problem. New theories, they're new because they contradict the old theory. They say something different. And as a criterion for accepting them, their acceptability, you want to say, well, maybe they should be able to account for everything that the old theory could account for, and something new that the old theory could not account for. So I mean, okay, so that's something else that I wanted. Now, you often talk about contemporary philosophy of science as somehow ignoring the impact that the use of a theory may have upon what it is studying. I mean, I really don't get it. It would seem to me that every instance of the application of a theory has an impact upon what that theory is studying. So, for example, you may have theories that study, the motion of comets. As a result of your theories that you've developed, you land a observing vessel on that comet. You have had now an impact upon the comet. This is what medicine is all about. It's what engineering is all about. It's not like this is something new that we've suddenly discovered that a theory may have an impact upon the phenomena. Look at where we are. We're in a building that was built using some scientific theories. the application of those scientific theories have had an impact upon the world in which we live. It's very clear. But that said, I want to be very clear myself that not all knowledge is scientific knowledge. There's a good deal of science, there's a good deal of knowledge that has nothing whatsoever to do with science. Your knowledge of the fact that I'm standing here talking to you. It's a true statement. It may or may not be important to you, but I don't think that it's part of scientific knowledge. So not everything is science. What is science are universal general theories, and you can use the term science in other words, maybe to the practice of research or the community of scientists or whatever. But when it comes to talking about these types of things, I think what we're talking about is really scientific knowledge. And for it to be scientific knowledge, at least in, what most of the philosophers of science were talking about, were universal systematic theories. It's one of the reasons, for example, why Popper did not say that all statements have to be falsifiable. He said that all theories have to be falsifiable. Particular statements that may refute a theory, such as here is a black swan that might refute all swans are white, those statements are not themselves falsifiable. They're verifiable. So, there's a lot of things that, I guess, we would regard as knowledge that have nothing whatsoever to do with science. It doesn't make it bad. It doesn't make it less elegant, but it does make it less universal and less applicable so that you can't draw as many inferences as you might have thought you could from it. Let me stop there and we can battle it out.
Okay, good. Thank you, Mark. Questions, comments from the group?
Mark, I have a comment.
We
I
can-
don't know if it's naive or not, but it seems to me I read the Post every day, and I find most of the headlines that talk about a new theory, new science, are not that. It may be sloppiness on the part of the journalist, but a single study indicating or suggesting something does not a theory make. But the whole society now seems to run based upon that as a predicate. Study said this, therefore. I could say, well, the high cholesterol scare of the 90s is a pretty good example, where they found that after 10 or 15 or 20 years of treatment, there was no significant difference made. My field, project management, goes through new methodologies with some regularity. The only thing they have in common is that they produce about the same quality of result.
I think that there may be a reason. I'm not sure whether this is a reason, but as a philosopher of science, I could understand that with the following notion, that there were philosophers of science, like the positivists, who did equate science with everything that was meaningful. If it wasn't science, it was nonsense. In a literal, it wasn't just non-science, it was nonsense. In a literal sense, that's what they meant. So I think that this produced an atmosphere, probably in the academy. They had a very strong influence in the academy, where if it wasn't science, if it wasn't good, and so everyone tried to be scientific. Quite seriously, I think that's why we have social science today. I'm very serious about that. I think that, and I think it's a bad thing. I think that it was much better, much more accurate, and much more meaningful and open to discussion when we had moral philosophy. I would say it even for natural philosophy. I think that what we found in the course of investigation of scientific knowledge over the course of the 20th century is that it simply could not be justified in the way in which people who originally made that distinction thought it could. So, in the 19th century, in the middle of the 19th century, you didn't have science. You didn't have, natural science. You had natural philosophy, which underscored the idea that all of these things were subject to further investigation and debate. And Newton's theory, kind of changed that for a while because everyone began to accept it as being final. But the joke was that in the beginning of the 20th century, when the social scientists were saying, oh, we want to be just as good, how do we do that? We have to follow the scientific method. physics was exploding. I mean, there's been at least 3 revolutions in physics alone, like in the past 100 years. So I think that may be part of it, but it's also that, what can you say? People are generally ignorant. I mean, ask, the fun thing that I like to do when somebody says that, studies say, oh, what was the study design? What was it about? I mean, that's as far as it goes. You never get it any further than, going to that.
I thought you told me.
I just would like to ask other presenters to comment a little bit about the big data influence on concept of science in your thinking.
We've been discussing that in the CybCom listserv, which is a cybernetics communication listserv. And I guess I started it off because I referred to this article in the New Yorker just recently on the experiment that Stafford Beer did in Chile in the 1970s. And they said, in that article, they said that was the first study of big data. But I said there was a fundamental difference between what Beer was doing, because he was using a theory of adaptive behavior, Ross Ashby, which he had modified and built a model of a viable system. And so the theory was telling him what data he needed to collect in order to create an adaptive, viable system. And big data is the reverse of that. You just take all the data that's coming into your computers from customers and suppliers and so forth and set some algorithms to work to try to glean some interesting relationships from it. So it's a completely different idea. The big data idea is completely different from hypothesis testing or theory-guided inquiry. And then the conversation sort of evolved in the direction of the situation room. One of the things Beer did was he designed a situation room, sort of where decision makers would get together and they would see screens of data and then they would make decisions and so forth. And we started talking about situation rooms, and the conversation moved in the direction of how that's not really so important. The statistics that you use, the data that you bring into the room, and so forth. What's really important is the conversation that occurs in the room and how you manage the conversation in the room. And if you look at the history of management cybernetics, that has been the shift. That you start off with sort of a mathematical operations research point of view, and then you move in the direction of a facilitated conversation to create a strategic plan or a set of ideas on how you're going to act. And Beer did that. He started off with his neurophysiological model of a viable system, and then he developed what he called syntegration, which is a facilitated conversation. John Warfield did the same thing, starting off with operations research and then went into interactive management. And if you look at the military, international development, people start off saying, well, what does this country need? Well, they need roads and they need electric power. And then you say, well, no, okay, we've done that, and they're still not getting the idea. So what they need is macroeconomic policies, a balanced budget, and so forth. And that doesn't quite seem to turn the trick. And so they go into other things. But there's this movement toward a kind of anthropological understanding. Well, what do these people think they're doing? Why are they doing that? And how does what we think they need plug into what they think they need? And so there's this multifaceted, from many fields, many theorists, toward conversation and ideas. And what are people thinking? So my conclusion from that is that it's really very helpful to look at what people are thinking, to look at observers and to talk to them and say, how do you see this? As opposed to coming in with a kind of expert knowledge and say, well, this is the problem, okay, and if you do this, then your problem will be solved. And many times people don't act on the recommendations. So I think second-order science will help in that regard. because it will look at the psychological, sociological, and anthropological things, and it will emphasize participation, getting people into the conversation and letting people have a say, and then figuring out how you can move the group forward.
So you're saying the second order science is sort of like democracy?
It's very compatible. Yes. And you can look at the history of the Soviet Union and their interpretation of cybernetics.
All I want to say is that policy is very different from science. Yeah, science is one thing, policy is another. In my response to your paper, several times I had to say, everything is what it is and not something else. Methods are not models. Models are not theory. I mean, these are different things. If we mesh everything together, then what you have is a mess.
Shall I say? I would like to start the answering by looking at the way social sciences, or we as citizens of a society, were informed about ourselves in previous times, so 20 years ago. What were the methods where we found out something about society? It was social scientists doing surveys. So they selected a sample of 500, 1,000 persons or so, and then went out, conducted these surveys, came back, made their tables, calculations, and so on. So it was we had very little access to what people actually were doing, because it was focused on what people were saying they evaluated highly, or what they did, and so on. And people are very, very fallible, and they're wonderful experiments. So this was the primary data source. And it's being used as an important data source to make surveys, and now we have not only surveys, panels, and so on. But in the last 10, 15 years, we have an enormous new wave of data where we can actually see what people are doing. Shopping, for example. And if we would ask them what they are usually shopping, they would give us rather inaccurate answers, but looking at all the shopping information, the people themselves would be surprised to find something about their ways of doing things like that. So we have an enormous new wave of data, and if we think back on the three levels, it's a challenge now for all three levels, because the data are there, but currently it's almost impossible for social science data archives or researchers to get access to these data. So it has to be negotiated on a case-to-case basis, but these data are not accessible. It's a huge problem for the data archives at the zero-order level, because they cannot somehow store or so far we haven't found ways to store them so that they can be accessed at the later dates, and so we could see what happens in the United States between November 20 to November 30. It's currently not possible to go in 1 year to the big American data archive and find. So that's at the zero-order level a big problem, get access. At the first-order level, it's a big problem of finding ways to new methods to deal with big data issues. And there are now several new methods around, a lot of them working with visual means. So you get visualizations and patterns as meaningful patterns as results of these analysis of big data analysis. And there's also a big challenge of patterns of patterns. So if you compile several of these big data blocks and so on, and look for even more general patterns. So it's a big challenge. It's a huge challenge, but it's in terms of getting information about the society we live in, it's a terrific opportunity, and it should be used foremost by scientists and not by national secret agencies and so on, which are currently the big users and not us who are concerned. Yeah.
Can you pass the mic on to Jonathan?
I have two questions which are not related to each other. The first is just a question of what is the relationship between an observer and consciousness. Is the observer assumed to be conscious in the first order cybernetics, or what? Can somebody summarize that for me?
I guess in my work, I've assumed consciousness of human actors. I haven't thought much about it. You have a thought on that, Carl? Are the observers conscious?
That's your responsibility.
I mean, I'm on the hook. Well, you can certainly say that human beings do all kinds of things they're not really conscious of. When I'm driving the car, very often I'm not thinking about exactly what I do. And Carl has seen me miss a turnoff because I was talking at the same time I was driving. So we do lots of things in a subconscious mode.
I thought he was referring to something like a device that records data of some kind, as opposed to someone who is observing.
Oh, no. You certainly don't need consciousness in a recording device. I mean, just look at all the data that's collected automatically. And now with the Internet of Things.
So is there a difference in your thinking as a result of the fact that you might be dealing with a conscious observer as opposed to a recording device? But you see, the difference there would matter at the front end more than at the back end. You see what I'm saying? So the design of the research experiment, the consciousness of the observer is significant. But in the actual observing of the experiment, not so much.
I've been puzzling over a book called The Quantum Enigma, Science or Physics Encounters Consciousness, and they're saying that only a conscious observer can collapse a waveform into a particle and give it its history going backward in time. You cannot do that until the consciousness enters the picture, which seems like it's an argument for second-order cybernetics being very important, which is the nature of the observer that's creating the phenomena that you're looking at. And so I was just curious about your reaction. The other question I have is to ask the second-order question of, would any of you comment on how you would take a position that would incorporate everything that's been said here, so that we're not looking for truth of are you right or are you right, but what encompasses everything?
Yeah, I find that an extremely useful point of view that is looking for an overarching frame of reference. And in my comments, in reply to the comments on the Target article, I tried to do that by not taking the position that realism is right or constructivism is right and the other epistemologies are wrong, but just saying that these are ways of thinking about how one interacts with people. And depending on who you're interacting with, if I'm interacting with a plumber, then realism is really useful. Constructivism is a distraction. And so forth. So it depends on who you're talking to, how you phrase your arguments. With regard to what you were saying earlier, it made me think about the fact that as automation progresses and robots and stuff like that, we're going to have machines collecting all kinds of data. And then, of course, they report it to us in various ways, like they can tell us that a pipeline is about to break. But they could collect huge amounts of data, operate with algorithms, make what we would call inferences and forecasts, and warn us of things happening, maybe international development problems, or if you start computerizing economic data, they might say, this economy is getting out of kilter. I mean, human beings do that now. I was just talking with a financial person that says that pretty soon financial advice will be totally algorithmic.
No, I mean, certainly there are devices that can be used to observe. And certainly there are, without any immediate human intervention, ways that those devices can set off other devices to perform actions that don't involve any immediate human intervention. I mean, that's one of the reasons why this reflexivity, is present in physical science as well as in social science. But even so, it seems to me that that doesn't get to where people may want to go, because those devices have to be designed. They have to be programmed. There are assumptions that go into that. We are looking at this as opposed to that. We are drawing these kinds of inferences. All of that is in the design. So, you may think that you get beyond the bias that you're worried about and the prejudice that Stuart is worried about in the observer, because now we have these machines that can do it. But I think that it's only more dangerous and insidious, because you think you've gotten beyond the bias and you don't ask how those things were designed. It's sort of like, and it's terrible. We see this today so much with the, well, you see it very clearly with the climate, the so-called climate science. I, by the way, have a little principle that any name of a discipline that includes the term science in it is not a science, but it advertises itself that. But I mean, people think that because you have a model, you have a proof. It's just crazy, and to my mind. I think that where we may have common agreement is an understanding that scientific knowledge, and more importantly, we ourselves are fallible. We may be mistaken. Even when we think we have the best evidence and the best argument, we may find out that we're mistaken. And so there is always a need for further investigation and critical discussion. And by the way, when we say critical, rational criticism, observations of physical experiments are part of rational criticism. It's not, when you see something and you observe something, that very easily becomes a premise. I think this guy in the back end, Patricia.
Well, Pradeep's had his hand up.
Yeah, no, I thought I'd just say a couple of things. First of all, with respect to this consciousness and machines and so on, there is some very rudimentary work going on in robotics where machine learning and so on is making these people actually sense the environment and so on and so forth. So it's actually scary as to where that might end, and because that obviously might one day take us to a point where these machines have some sentience beyond just being able to take measurements and so on and so forth. But I had an earlier comment that I was just going to make and try to be brief, because first of all, I'm an interloper in this group. I don't know anything about cybernetics or second order science or anything like that. But based on everything that's been said here, I see a couple of ways to sort of bring all this together. I think Mark talked about the difference between social science and hard sciences. This is something we've been talking about for a very long time. And I think that the social sciences is where the observer matter becomes a little bit more critical. And there is a point in between social and physical science, say in medicine, where we do double-blind studies and so on, so that we do not have the observer introduced into the experiment, so to say, and affect the results. But I think that another thought that was expressed during the comments was about the purpose of all this. Is it trying to make something function better, or is it trying to make something more understood? And I think pure science is about understanding, whereas a lot of this policy stuff and social science stuff is trying to say how much better can we run this organization, how much better can we perform as a group, or something like that. So I think the purpose is not something we have discussed enough within this science discussion.
Tricia, did you have a comment?
I question, and it relates to what all the speakers have said, because we're talking about all this information we have today, all this data, and we know people have biases, but let's say take into account that everybody has a bias, so you can factor this in. Can we afford, at this point in time, with so much change going on in the world, afford to ignore all this information and not try to factor it in and find the methods to make it information that can be considered scientifically rigorous or whatever? But there's so much change, there's so much fluidity, and it affects every aspect of our lives. And if we ignore it, like he's talking about shopping, but you know, they have data on everything that affects our lives. And it just seems to me we can't, I'm asking you, can we stand still? Don't we have to find ways to incorporate all these changes? And so many changes have been going on because of data, because of technology. So I'd just like to know your feelings.
You know, I agree very strongly with what he's, I'm sorry, Pradeep said that you very quickly, and well, even in natural science, but far more quickly in social science, get into the incorporation of policy agendas as if it's science. And I'd want to say these are entirely different things. I remember when I was a kid, we were in the discussions, you know, the discussions at Columbia about theory ladenness, right? And we were doing this in, you know, consideration of physical theories, you know, theories in physics, and coming to the conclusion that theories in physics are both theory and value laden. Okay, and so that this was a significant challenge to their, if you will, objectivity. But what were we talking about? I mean, we were talking about assumptions like there are objects. That's a theory. I mean, we're looking at the world in terms of objects as opposed to processes, or that there are colors, right? Well, the next thing we turn around, and the social scientists are, you know, all of our theories are, you know, all of our science is theory and value laden, but they're talking about Marxism and, you know, all sorts of high order political theories, right? Which seems to me to be of a completely different aspect. Now, there's a lot of information. There's also a lot of misinformation. And there's a lot of disinformation, and you can certainly find a good deal of it on the internet. And so, I mean, do we want to take that all into account? Well, in some sense, but I don't think that we want to credit it all as true. And I think that that's where criticism comes in, where you begin to look for, basically, for the inconsistencies. And finding inconsistencies doesn't tell you what's wrong, but it does tell you that something's wrong. And then ultimately, I think you have to step back and, being aware of the inconsistencies, make a personal judgment as to what you think is true. But now, if you're never aware of the inconsistencies, you're not in any position able to do anything like that. And so basically, I do think that the critical approach, which was always the approach in classical approach in science, skeptical. I mean, Descartes took it too far, but you know, there was always the idea that we're not taking things based on authority. We're going to ask, you know, what is the evidence for it? There's the recognition that the evidence for it will never suffice to be enough to show it to be true, but we can see in certain cases that there are inconsistencies in the evidence, inconsistencies in the testimonies, if you will, and at that point you recognize you have a problem. And I think that that's the human situation. It's probably the best that we can do. I'm not sure, does that answer it, Patricia?
Well, I mean, I'm not an expert on this, another over here, but I'm just saying it is overwhelming because there is so much information out there, and people want to know what to believe, and sometimes it is very hard. There are so many debates going on, whether it's climate change or anything else, and you can have arguments on many different sides. But all I was questioning is that we can't ignore all the new data, but we have to be very vigilant, knowing that anybody can put anything out there. And so maybe the focus should be on how do we better assess, what, I don't want to say right or wrong, but, what
I
these
agree. I agree. I think that the traditional methods, though, are...
But don't ignore, I'm saying don't ignore all the new information. Just
No.
try to have better methods of evaluation, for example.
No, I agree. You can't ignore it, but I think when I say the traditional methods, what I mean is you look for consistencies and inconsistencies. And when you find inconsistencies, you recognize that there's a problem here.
Doesn't it lead you to the idea that the observer and observation should be included?
When I say that I'm not, of course there are observers, and of course we recognize that the observer has a role. You just can't take it much beyond that, because there's no general theory that you can develop for an observer, because observers are different. That's part of the problem. If all of the observers were the same, Kant had a theory like that. Like Kant, all rational minds were essentially the same. So we could guarantee our certainty because we all had the 12 categories of understanding. We couldn't be mistaken. If we were mistaken, it was just an indication that we were irrational. That was Kant's theory. But I think we've come to recognize that we are very different from each other. It's kind of obvious. We talk about the observer. Who's the observer? We have how many people in this room? And I point out to you that you are all occupying different spatial positions in the room. So while we're all in the same room, what I'm seeing is very different from what you're seeing. You're seeing me, I'm not. I'm just saying, we're different. Of course, the observer, you can't get away from him, but you can't make any interesting scientific statements about the observer or his role because it's too varied. There's no generalities. There's no universalities.
I mean, there are so many psychological experiments that the principal investigator and his expectations have an influence on the way the experiment is conducted. So you have these effects, so what's required at this point is that these effects are recorded, and the same in the ways social surveys are conducted, and the goals of the principal investigator of the group has important consequences on the outcomes. And normally they are not included, but the position observer inclusion requires that these things have to be part of the procedures. So all what Stuart wants to say, and you shouldn't make fun of it in this very strange way that observers are, you cannot, that the effects of the observers are to be included in the way the experiments are recorded, research is conducted, and so on. And this gives better assessment of observer effects than if you do it without. Stuart is not talking about a general theory of the observer, but the effects, concrete effects, empirical effects of an observer in doing research, and that this should be included in the research process, in the research design. Yes.
And what I am saying is that while you may know that an observer may have an effect upon what he observes, you don't know what that effect is in the case of any given observer. Even a very biased person, a very prejudiced person, may make a very accurate observation. Even a very objective, whatever that might mean, person may make a mistake. So I'm saying we know this, and that's part of the reason why I think we say our scientific knowledge is fallible, which is, by the way, I just want to point out, that is something which we have said only within the past 100 years. When we entered the 20th century, everyone thought that scientific knowledge was certain. If it wasn't certain, it wasn't knowledge. Everyone thought it was justified. So we have discovered over the past 100 years, or we have come to believe that it's fallible, primarily, I think, as a result of consideration about what observers can and cannot do and other things like that. But I don't think we can make any inferences, any useful inferences in any particular case, because we just don't know that.
Let me give some examples from the field of human resources management. Before you hire somebody, it's a good thing to do due diligence. In other words, does the person have a criminal record? You can have strategies for hiring certain people. For example, a lot of consulting firms like to hire graduates from Harvard, Stanford, Chicago, something like that. One company decided, well, we'll go to Cornell. It's a good school. And we can get more talent for less salary by going to Cornell than we can competing with these top-notch schools. So it's a rather sophisticated, developed field, human resources management, where you want people who are trained, you want people who have a personality that fits the work that they're going to do, and it's economically wise to engage in this kind of reflective thinking about who these people are. Now, I think that's sort of this practical approach to looking at the observer. If I see a statement in the press and it comes from Barack Obama, I interpret it one way. If it comes from the Speaker of the House of Representatives, I interpret it differently.
Is this science?
No, it's not.
It's practical life.
Yeah, but it is science. I thought you were talking about second-order science.
It has nothing to do with this discussion, in my opinion.
Okay.
Where I thought you were going in the beginning of your talk was essentially the end of field universe, where science was not driven by a perspective on a particular discipline, but was driven by purpose and question. Like you might have a question you want answered. And the universe we're operating in is now so unified that you have umpteen different methodologies, umpteen different perspectives, umpteen different sources of data, and they're all accessible via the internet or whatever tools you might use. So that science is evolving. I don't know that yes, it is. So a second order derivative of something is where that something has gone in response to forces that are on it. So you could consider second order science to be that universe, because it is based on everything that went before, right? But it draws a circle around it such that the scientist is in the middle of it and is accessing all of those.
Okay, let me try to reply to this notion, is it science? It depends on what you think science is. If you think that science is the way Mark has described it, then I would say, yes, that's not science. However, for the last 70 years, there's been something called cybernetics, which is a theory of purposeful behavior. It's a theory of adaptive behavior. It's a theory of how you get along in the environment, of how you achieve your goals and your purposes. And if you can develop training materials, hiring procedures that help you create a profitable company, that is easily within the realm of cybernetics, that I would say. And to me, cybernetics is a science. At least it tries to be.
But Stuart, a large part of what you're writing
is in criticism of contemporary philosophy of science. So, I mean, if it's simply in praise of cybernetics, but it's in criticism of contemporary philosophy of science. And so contemporary philosophy of science does not take into account the observer. I think it has always taken into account the observer. Contemporary philosophy of science does not recognize the impact that the application of theory may have upon the world. It has always done that. I mean, how would anyone do medicine? I mean, think about the consequences. So what you're saying is you're criticizing contemporary philosophy of science. It needs to be expanded. This is what you say in your article. It needs to be expanded to take into account the observer and the impact that a theory may have upon the world. It just seems to me that it's done that. It's always done that. It also seems to me that it can't go all that far beyond the basic recognition that observers may be fallible. What do you say? I can't say, well, Karl's going to be fallible because he's biased. Well, maybe I know he's biased, but I can't say that he'll be mistaken in this particular case. I mean, just because of that. I mean, you can't make those inferences. If you had a general law, propose a general law. Newton proposed a general law. All bodies will move in a straight line unless deflected by an external force over infinite time and space. That's a universal law. You can criticize it. Propose a general law that is true of all observers. Beyond that, they may be mistaken, which is what we know.
Can I say something? The general law in the field of social science is much harder to come by. So your point earlier, Mark, is very true, and that is that in the quest for gaining scientific credibility, the social sciences on campus attach themselves to terms like science. And I think that word science has to be defined as to have what purpose it is serving. If it is hiring better people for company X by going to Cornell, that is fine. I mean, but that's not science, in my opinion.
Right. I mean, this is the thing that I want to say. I do think that because of the excesses of the positivists, where being scientific was associated, that's the only thing that counted. If it wasn't science, it was nonsensical. But we know that's not right. There's plenty of stuff which is true and important and, you know, good practice and X, Y, and Z, whatever you want to say, but it's not science. And to think that you can draw inferences from those maybe rule of thumb rules that you might articulate, I think is truly dangerous. I think isn't that what discrimination and prejudice has been traditionally all about? I mean, like, you know, drawing inferences that may not apply to individuals because you have some.
Let me add a little bit to the discussion. I once wrote an article called Should Knowledge of Management Be Organized as Theories or as Methods? And basically what I observe is that a great deal of management takes the form of rubrics or methods. Not research methods in a sense, but simply methods for holding a conversation, a strategic planning exercise, or how to fill out a business plan, or what procedures to go through when you're hiring a person. There's just lots of methods in management, and these have been developed as a result of an experimental process. That is, you try it, and then you modify it, and then you try it, and then you modify it. And so there has been an experimental activity that has led to the development of these methods. They've been found to be useful. People that use them do better than people that don't. And yet, within the field of management, people seem to be trying to imitate physics. And this is different from physics. So they think, well, that's not theory, that's not doctoral dissertation work. Those are just methods. Those are management methods. Well, that's true, but they're useful for purposeful activity. And so I think we need to have a different conception of theories and methods in social science.
If I may. So you worked with Hans von Forster, and Karl is influenced by him as well. I worked with Karl Popper and was influenced by Popper. Popper was very often criticized for focusing his philosophy of science too closely on physics. But Popper has said the general method of all scientific inquiry, and indeed he says of all rational discussion, is something like this. You have a problem, you put forth a tentative theory to solve it, you try to eliminate the errors in that theory through criticism, and then it typically leads you to a new problem. Isn't this exactly what you just described as being the non-physicist approach to science in management? This is exactly what Popper has always said science is all about. Problems, tentative theories, eliminate the errors in those theories, you go on to a new problem.
Right.
Well, there must be something wrong there. That's the method in physics. That's the general method of science. I mean, why is it so peculiar to physics suddenly?
Okay, that is why I talk about how you describe systems, how you variable ideas, groups, events, and so forth. When you're describing a method, like how to bake a cake, or how to do a strategic plan, or how to set up a business, you don't have variables, and you're not establishing relationships among the variables, and you're not checking those variables with a data set. But they're steps, they're procedures, they're things